Gravitational lensing is what I work with in a lot of different sort of aspects of my research. It's more of a tool than the pure topic of what I do. But fundamentally, it's a phenomenon that happens when gravity bends light and produces what we call lensing, which is works in exactly the same way that like a glass lens bends light in, say, a pair of glasses or a magnifying glass. It's just the gravity is doing the bending of the light instead of a material like glass. So if we have an observer over here on Earth and we observe a source in the sky, the galaxy would normally appear to an observer to be located right here. But the gravitational lensing effect causes light from the background galaxy that's traveling through space in some other direction to be deflected and bent down and redirected to the observer. Intrinsically, you don't know that light has been bent, right? If you see light, you just assume it's coming at you from a straight line. In case an observer would see this, it would see an image of this galaxy at both this position on the sky and this position on the sky. And that's because light was deflected by an intervening source, what we call a lens, which is really just a large concentration of mass. And that produces images in the sky from two apparent locations. Because it's lensing, and I said it works like a magnifying glass, it literally does magnify things. So when this happens, the background galaxy has been magnified. So it's literally brighter and bigger and easier to study than it would otherwise have been. So we use lensing to do that. And then the other sort of slightly more complicated side of things is that in astronomy in general, we're really limited in what we measure, right? We can only ever measure, basically detect light. We can catch light. And then from all the light that we catch, we have to infer all the physics of the universe. So we can't measure the mass of a thing in the way that you can in the laboratory. We can't like weigh it. But we have to come up with clever ways, or therefore we have to come up with clever ways to try and infer things like mass. So lensing is actually a really great tool for measuring the masses of these intervening lensing structures because we know the laws of gravity. And if we can measure these deflections, then we can actually constrain how much mass is causing the deflection. So it's actually a really great tool for not only studying distant magnified background sources, but also for actually studying the physical properties of the things that are doing the lensing.
Do you love science? Of course you do. So stay up to date on all things science around Cincy by subscribing to our channel and follow us on Instagram and Twitter @SciAroundCincy.